Well, hello friends, and welcome back to the channel. Today, we're going to be doing an educational video. A lot of my blades are missing something kind of important. My touch mark. Now, I used to have a stamp that I used, but it would kind of bulge the knife out, and I'd get weird warping sometimes when I was trying my heat treating because of it. So I'm moving away from that, and I'd like to start electro-etching my touch mark. Before we get started, let's talk about something. Electro-etching has already been around for a while, so you can already buy etchants specifically for the metals you're working for, and the electro-etching generators themselves already exist specifically for this purpose. However, we all know that as beginner knife makers, we may not have the money to just go out and buy some of these. So, what we're going to be looking at is doing it for cheaper or with stuff that you might already have laying around the house. First off, let's discuss our etchant solution. Now, the main electrolyte that we're going to use is salt. There's a couple of different additives that we're going to try just to see what the results are. Here we have white vinegar, we have lemon juice, and we have ferric chloride, which a lot of knife makers usually have on hand, but probably the hardest one to get your hands on. And then also, we have distilled water, and it's very important that we use distilled water and not other waters, just because the minerals that may exist in them can affect the electroconductivity of your etchant. Also, water is important to have in there. Now, a lot of people think that the stronger they make their solutions, the better they're going to etch, when in reality, your etch forms an oxide layer, and a lot of the times, your etchants can't dissolve that oxide layer, so you need a little bit of water to help dissolve that oxide layer. Otherwise, you do your first pass, and then it just creates an electrically resistive barrier. After etchants, we're going to discuss cleaning just a little bit. It's very important that you have a clean surface before you etch. Now, the first one is isopropyl alcohol, probably the safest one to work with, and it works pretty good. Next, and the one that I recommend for this, would be acetone. You got to take a little bit better safety precautions with this, but it works even better than the isopropyl. The last one we're not going to try, but is brake cleaner, and that usually cleans everything to within an inch of its life, if not beyond. Last, we're going to discuss our power supply. Now, for the really cheap side, I've seen people use 9-volt batteries, so we're going to give that a try. For mid-range, something that we all likely have lying around is a car battery charger. These work pretty good from what I've seen, but I do know that one thing that is kind of a problem with these is they are smart. They do know that they are not charging a battery, and sometimes they will just shut down on you, so sometimes you gotta go back and forth with them. Lastly, we're going to try a home-built version out of a Variac. However, this supplies AC power, and we're going to need to convert it into DC, so we'll do a little bit of a montage while we build our diode bridge rectifier. However, whenever possible, I would suggest just going out and buying a device specifically for electro-etching on this. This is the part where budget comes in. What can you afford? What are you willing to put up with? So before we get started, time for the ironic disclaimer. We're going to be messing with electricity on this part, so what you're seeing, don't do at home. Alright, let's get moving on. This is the Variac I'm going to be using to control my flow. It's going to output AC current. That will be leading to my little diode bridge rectifier that I have here, which converts it from AC to DC. I pulled this out of a project I've already been doing, but it's a pretty simple thing. Maybe I'll put a wiring diagram up for you to see. That will all be housed by this little case that I have here, just to keep all of the leads and exposed wires out of the way so that way you don't accidentally touch them. I'll install an on-off switch for safety, alligator clamps for hooking directly to the project, the wire that the rectifier will be used to connect directly to the Variac, the wires, and some connectors with the proper tooling, and a voltmeter so I can make sure everything works before I plug it in. And I'll be attaching the components to this board here so that way they're not flopping around and touching each other. Time for a montage. Well, as you can see from the scorch marks and my diodes laying there, this didn't work when I turned it on. I had things reversed or just had my variac turned up too high, but those did not work. So I'm going to order more of those and we'll see this thing on a different video. So we're just going to stick to the first two methods that I told you about. After that disaster, we've reached the part of the video where it's time to mix up our Electro-Etchant. First off, I always suggest having the proper safety tools. Whenever working with chemicals such as acids or anything else corrosive, I always suggest you wear splash resistant eye protection. So next, even though I just washed these, we're going to rinse both of them out with distilled water. Just to make sure they're extra clean. It'll help get repeatable results. We're going to mix up a bunch of the salt water ahead of time and use just from this container to mix all the other etchants, so that way we have a baseline for all the other etchants. Perfect. Now that we have all of the salt dissolved into our distilled water, we'll portion them out equally and then add the same amount of etchant into each one. Now that we're ready to break into all the other chemicals, we're going to put on entirely the proper attire, just for safety measures. You never know. Here I have equal portions of the salt water in each vessel, except for this last one. We're going to mix everything in here just for an experiment, And seeing as how we don't know how these acids interact, we're going to make a very small quantity of this. Additionally, anything with the ferric in it, I'm putting in the glass containers because I just don't know how the ferric's going to react with these plastic cups. So now we'll go ahead and mix equal portions of our acids in each one. To ensure that everything is equal, we will be performing the test on this bar of W2 that I have. I ground the mill scale mostly off of this face here. Now we'll clean it up really quick, and then after that we'll lay out some tape so we can have precise etching strips and label everything so we know, and then start our etch. First, we're going to be trying the very poor man's method. Two 9-volt batteries hooked together with the positive connected to the material you're etching and the negative to the cotton swab. Doing it this way makes it so that way it will etch the metal. If you do it backwards, it's depositing an oxide on the metal, which a lot of the professional ones will actually have both an etch and a darken, and all it's doing is just switching the polarity. But for this particular run through, we're going to be doing everything on etch, because that's what we're testing here, is our etchants. To keep things consistent here, we'll be using a 2 seconds on, 2 seconds off, over and over and over, the same amount of times on each one for both the 9-volt battery and the battery charger, just for consistency so we can really get a true judge of everything. Before we get started on this side, I would like to say that that previous charger that I showed you definitely was one of those ones that's smarter than I am, and it knew this wasn't a battery. However, this one can be tricked, so we're going to use it. It's lucky I have this one on hand. I don't know how long it'll be tricked though, so let's just get going and hopefully we can get through this. Okay, we have etched both 9-volt and the battery charger with all 5 solutions. Let's peel this tape off and see which has given us the best result. Conclusion time. After trying both methods, I would say that the 9-volt battery, 2 of them together, actually gave a surprisingly good result over the battery charger. The battery charger tried to etch the entire thing at once, a much larger area, and it really wanted to focus on what was directly beneath the wand. Whereas the cotton swabs with the 2 9-volts, the even motion back and forth allowed it to concentrate in one little spot, and I was able to get much more even results with the cotton swab and the 9-volts than I was with the battery charger, surprisingly. Next, let's talk about which etchant was the best. Now right off the bat, I gotta say that I noticed when I was etching with these two, I could smell slight hints of chlorine, which makes sense. The ferric chloride is electrolyzing and the chlorine is probably coming off in a vapor. So right off, I would say these two you don't want to use. And the ferric itself actually gave a surprisingly shallow etch, so it's not at all really good. Next, the salt water alone did alright as expected, but I'd probably say the 2 deepest etches were the vinegar and the lemon. And from the looks of it, the lemon gave the more even etch, but the vinegar gave the deeper etch. So all in all, I would say whenever you're trying to make your etchant, I would go with heavy salt, distilled water, and either vinegar or lemon. You might even try mixing both of them together. And now the part we've all been waiting for, to etch my touch mark on here. These came in the mail just in time for this video. A whole sheet of my touch mark. Now I've got to give a shout out to Alan Strickland. He was the one who sent these to me, and he did it for the right price, and he did it very quickly. I was impressed. So I'll put his information down in the description, so if any of you are interested, you can find him. Well, looking at this, I'm definitely pleased. I'm certain I can refine my technique a little bit more, but that's good. Let's take a look at this. Alright, so the conclusion is that for the poor man, a 9-volt battery with salt water and vinegar or lemon juice is probably your best bet. However, I would always recommend that when you have the opportunity, go out and get the professional equipment, because we're eventually all looking to be professionals, right? A couple of things I'd like to touch on before we leave is that safety is always first. It's always better to be too safe than not safe enough. And when handling corrosive chemicals, always remember to dispose of them properly. Neutralize your acids and take them to wherever you need to. It's always better that way. You never know what's going to be getting into them later, and it's better that they're taken care of safely than having somebody else find them and have an accident. Once again, I'd like to thank Alan Strickland. I probably didn't use his stencils exactly how he wants them to. I need to read up on that a little bit, but they did work really good. And each of those, can, depending on how you etch, can be used several times according to him. So if you look at that, that entire book is going to give me hundreds of knives. Well, by this point, I'm pretty certain you know the drill. Give me a like and subscribe if you haven't already. It really helps me out. And if you have any ideas for future projects or you just have some general comments, please let me know down in the comment section. Thank you, and we'll see you next time.